Hey guys, this is the last section we're doing in chapter 3. It's systems with 3 variables. And if you like solving using elimination and substitution with 2 variables, 3 variables may make you want to pull out your hair, but you also have like this huge sense of accomplishment when you're done. So for our objectives, we're going to be answering the question, how does having a third variable change our approach to solving system of equations? So we're going to solve using elimination and using some substitution and some combinations of the two. Okay, so first I'm just going to go through how you solve using elimination. So here's our problem. Here are our 3 systems of equations. See, we have 3 variables, x, y, and z. So what we're going to do is we're going to eliminate one variable only. And if you look, the z's, we have a positive, we have 2 negative ones. So this is going to be really easy to use this. Alright, and then after we've eliminated z, then all we have left is x and y. So then we're going to use those new equations and solve for x and y, and then we're going to go back and substitute our x variable, our y variable, and find our z variable. And then we're going to write it as an ordered triple, an x, y, z, alphabetical order. Okay, so let's get started. So I'm just going to go ahead and do, since the first one is positive, I'm going to do the first one and the second one. And then after I do the first and second, I'm going to do the first and the third one. Okay, so we have to do it twice to get rid of our variables. So 2x minus y plus z equals 4. And x plus 3y minus z equals 11. So you see, if I just go ahead and add straight down, I get 3x plus 2y equals 15. So there's one. Then for the other one, when I add them together, 2x minus y plus z equals 4, and 4x plus y minus z equals 14. I'm also going to go ahead and add these straight down. I get 6x equals 18. Now, this one's really nice because the y's and the z's canceled, so I don't have to do it again. So I'm just going to go ahead and solve this one for x. Divide by 6, I get x equals 3. I'm going to take that, x equals 3, and since I've already solved this one for x and y, plug this in for this x here. So 3 times 3 plus 2y equals 15. So this is 9, so I'm going to subtract 9 from both sides. So I get 2y equals 6, divide by 2, y equals 3. Now, since I know x is 3 and I know y is 3, I can substitute those both in for my x and my y in any of these equations. I'm going to go ahead and just do the first one. So 2 times 3 minus 3 plus z equals 4. 2 times 3 is 6. 6 minus 3 is 3. So I have 3 plus z equals 4. Subtract 3 from both sides. I get z is 1. So I write this as an ordered triple in alphabetical order, 3, 3, 1. And that is my solution. So this is basically what we're going to be doing, just eliminating, getting down to one variable, and then back substituting. Alright. So why don't you go ahead and try this one. I'll also work it out and post it here in a second, but I want you to try and do it before you see what I got. Just first, what do you see any that are going to be really easy to solve for first? It should be y, because you have 2 negatives and a positive, so you can add 2 of your equations together. Okay, go ahead and get started. Okay, hopefully you were able to get this far. So we have 2 equations. I've eliminated y from both of them, and I just have x and z. So I'm going to take and I'm going to multiply this top one by negative 3, multiply this bottom one by 2, so that I can get rid of the x variable. That will be able to cancel the x variable for both of them. So if you haven't done so, go ahead and pause right now and keep working. Okay, I went ahead and solved those. I got z as negative 3. Now I can go back to either one of these equations, either one, and plug that negative 3 in. I'm going to go ahead and choose the top one. I'm going to plug negative 3 in for z. So I found y and I found z, or x and z. I'm going to go ahead and plug that into, it looks like my first equation is the easiest. So I'm going to plug in x and I'm going to plug in z so that I can find y. So 4 minus y plus negative 3 equals negative 1. Okay, 4 and negative 3 makes 1, so I have to subtract 1 from both sides. So negative y equals negative 2, therefore y equals positive 2. And then we go ahead and write all three of these as an ordered triple in alphabetical order. So 4, 2, negative 3. There is our solution. That should satisfy all three of these equations. And if you're not sure, you go ahead and you plug all these back in to each one of these equations and check and make sure it satisfies all three of them. You can also use substitution if you have something like this where you have two variables and then three variables. You can solve one of them and then plug into the other two. So these are the steps you go through. Choose an equation. I would solve for x because it looks like there's x in both the second and the third equation. And then substitute that into both the other two equations, simplify, and then use the two new equations and solve for y and z using elimination. So that's how you would do those. I'm not going to make you do this right now. And that is all. So I hope that you understood what we're doing. It's going to take a lot of practice, a lot of time. You just have to do it over and over and over again, and don't get discouraged. And if you get wrong answers or weird answers, just be willing to go back and check, look at your work, be really patient, and then enjoy the success when you get it.